The afternoon of December 17, 1944. The Belgian village of Bullingen. Snow on the ground. The temperature is 23 degrees Fahrenheit. An SS Obersturmbannführer named Joachim Peiper, commander of the Spearhead Kampfgruppe of the 1st SS Panzer Division Leibstandarte Adolf Hitler, has just driven his column of Panthers and Tiger IIs into the village. The Americans defending it have fallen back. The streets are littered with abandoned American vehicles. Peiper sits in the turret hatch of his lead Panther and looks at what his troops have just captured. It is an American Army fuel dump. 50,000 gallons of gasoline in 5-gallon jerricans stacked in neat rows in a field next to the road. The cans are painted olive drab. They are stenciled with white block lettering that reads U.S. Army. The gasoline is high-octane, 80 motor transport, refined in Aruba or Trinidad or the Gulf Coast of the United States and shipped across an ocean to fuel American tanks that have, somehow, just abandoned all of this fuel and run away. Peiper does not understand it. He has been told that the success of the entire German counterattack depends on capturing American fuel because Germany itself does not have any. He has been told that his Kampfgruppe has been issued enough fuel to advance perhaps 100 kilometers, and that beyond that distance, his tanks will stop. He has been told that the Meuse River, his operational objective, is 180 kilometers from his starting point. He has been told to capture American fuel or fail. He gives the order to refuel. American prisoners are forced at gunpoint to pour the gasoline into the German tanks. The column drinks the 50,000 gallons in less than 2 hours. And then, because the German operational tempo demands it, the column moves on, west, toward Stavelot, toward more American fuel that the planners have promised will be there. What happens over the next 6 days will tell Peiper, in the most direct way possible, that the war is over. Not the war he is fighting, the whole war, the Reich, the Wehrmacht, everything. The 50,000 gallons at Bullingen were not what made the impression. The impression came afterwards, slowly, as Peiper's column moved west and encountered, in village after village, evidence of an American logistical system that was operating at a scale his army had never imagined possible. There were jerrican stacks in cow pastures. There were tanker trucks in church courtyards. There were 5,000-gallon collapsible rubber bladders draped over hedgerows. There were rail tank cars on sidings outside small Belgian towns. The Americans had brought fuel. They had brought fuel everywhere. Every divisional rear area had a fuel dump. Every regimental support unit had a fuel allocation. Every supply depot had reserves that by themselves exceeded the entire combat fuel allocation of Peiper's Kampfgruppe. He told his interrogators in January of 1945, after his column had been destroyed and he had been captured, "We began to realize that we had insufficient gasoline to cross the bridge west of Stoumont." The understatement is what makes the line memorable. He had begun to realize. He, a senior officer of the Waffen-SS, commanding the most heavily reinforced armored battle group in the German Western Front offensive, had begun to realize by December 19, 1944, that the operation was over because the gasoline was not where the Germans had been told it would be. The Americans had not abandoned their fuel, they had moved it. The Red Ball Express, that strange American institution of trucks driven mostly by black soldiers, had been racing through the back country of Belgium for days, hauling fuel out of the path of his advance and burning what they could not move. This is the paradox at the center of the Second World War in Europe, and it is the paradox that German operational officers, almost without exception, could not psychologically accommodate. Germany had begun the war as the most industrially advanced state in continental Europe. It had the world's best engineers, the world's most disciplined chemists, the world's most sophisticated synthetic fuel industry. By 1944, all of this had become irrelevant. Germany was running out of fuel. America, on the other hand, had begun the war as a country that owned a substantial portion of the world's oil reserves and that, through industrial choices made in the 1920s and 1930s, had developed refining technology that none of the Axis powers could match. By 1944, America had so much fuel that it was distributing 500,000 gallons of aviation gasoline a day to its own forces, another 200,000 to the British, another 100,000 to the Soviets, and still had enough to leave dumps unattended in Belgian villages for fleeing armies to find. The German officer who looked at this situation, from the Eastern Front to the Western Front to the Mediterranean, was looking at the operational consequence of an economic fact that German planning had refused to confront for a decade. This is the story of how that gap opened. The popular history of the Second World War spends most of its energy on the famous things. The tanks are famous, the Tigers and Panthers and Shermans. The aircraft are famous, the Spitfires and Mustangs and 109s. The generals are famous, Patton and Rommel and Zhukov. The battles are famous, Stalingrad and Normandy and Kursk and the Bulge. The trucks are not famous. The pipelines are not famous. The 5-gallon cans, the tanker ships, the refinery cracking units, the loading docks at Lake Charles and Beaumont and Aruba and Curaçao, these are not famous. The men who drove the trucks and operated the loading depots, the African-American truck drivers of the Red Ball Express, and the merchant marine sailors on the tankers, and the Texas roughnecks pumping the wells, and the New Jersey refinery hands cracking the heavy crudes, these men are not famous either, except in the small communities of historians who understand that the Second World War was, more than any other war in human history, decided by oil. The fronts that mattered, in the end, were not at Bastogne or Caen or Anzio. They were at Luna and at Ploesti and at Standard Oil's refinery in Bayway, New Jersey, and at the fueling stations at every American supply depot from the Channel Coast to the Rhine. The gap between American and German fuel availability in 1944 and 1945 was the largest logistical disparity ever recorded between two industrial powers actively fighting each other. American oil production in 1944 reached approximately 5 million barrels per day, of which the United States consumed about 3.5 million barrels itself and exported the rest. German production, including domestic crude, captured Romanian crude from Ploesti, and synthetic fuel manufactured from coal, peaked at approximately 124,000 barrels per day in the spring of 1944. That is 1/28th of American daily oil production at the same moment. A single American oil-producing state, Texas, produced more oil per day than the entire industrial output of the Third Reich and all of its occupied territories combined. California produced more oil per day than Germany. Louisiana produced more oil per day than Germany. This was the structural reality that underlay everything that happened on the battlefields of the Second World War. It was not a temporary condition. It was not subject to clever operational improvisation. It was the bedrock of the war. The Germans had no oil. The Americans had more oil than they could measure. Germany has almost no oil. There is some in fields scattered across Lower Saxony and around Hanover, but the total domestic production has never been more than a small fraction of what German industry has consumed since the internal combustion engine became economically important in the 1890s. Before the First World War, Germany imported most of its petroleum from Russia and from the United States. During the First World War, the Royal Navy's blockade cut Germany off from both sources. German strategists, after 1918, understood that any future European war would require Germany to find a way around its oil shortage. The materials Germany did possess included coal. Coal in enormous quantities, distributed across the Ruhr, the Saar, Silesia, and the lignite fields of central Germany. And coal, German chemists had discovered, could be converted into liquid fuel. The Bergius process, invented by the German chemist Friedrich Bergius in 1913, hydrogenated coal under high pressure with hydrogen gas to produce liquid hydrocarbons that could be refined into gasoline, diesel, and aviation fuel. The Fischer-Tropsch process, developed at the Kaiser Wilhelm Institute in Mülheim in the 1920s, used a different chemical approach. Both processes worked. Both processes were expensive. In the political climate of Weimar Germany, neither attracted enough commercial investment to scale up. The technology existed. The factories did not. That changed in 1933 when the National Socialist government came to power and made synthetic fuel a state priority. IG Farben, the giant German chemical conglomerate, was contracted to build large-scale Bergius hydrogenation plants. The flagship was at Luna, near the town of Merseburg in central Germany. Luna was expanded throughout the 1930s into one of the largest chemical plants on Earth. By 1942, Germany had 25 synthetic fuel plants in operation. At peak production in early 1944, these plants delivered approximately 124,000 barrels of fuel per day, of which over 92% of all aviation gasoline used by the Luftwaffe was synthetic, manufactured from coal. The synthetic fuel program was a genuine engineering achievement. It allowed Germany to mechanize its army without access to any significant petroleum reserves. But it was vulnerable in three ways. It was vulnerable to bombing because the plants were enormous, fixed installations. It was vulnerable to interruption of coal supply, and it was vulnerable to the simple fact that synthetic production, even at peak, was not enough to support the kind of mechanized warfare that the Wehrmacht's operational doctrine required. The other source was Romania. The oil fields at Ploiești, north of Bucharest, produced approximately 120,000 barrels per day at their peak. Ploiești became one of the most heavily defended targets in Europe. The most famous raid, Operation Tidal Wave, on August 1, 1943, sent 178 B-24 liberators of the 9th Air Force from bases in Libya. 54 bombers were lost. The damage was repaired within weeks. It would take another year of sustained Allied air pressure, plus the Soviet ground advance that captured the oil fields outright in August of 1944, to remove Ploiești from German production. The situation across the Atlantic was structurally different in every dimension. The United States in 1939 was the largest oil producer in the world by a wide margin, with daily production of approximately 3.5 million barrels. Oil had been the foundation of American industrial life since the 1860s, when the first commercial well had been drilled at Titusville, Pennsylvania. Texas, Oklahoma, Louisiana, California, Pennsylvania, and a dozen other states had functioning oil industries. By 1940, American refineries were producing aviation gasoline of 100-octane rating, manufactured using a catalytic cracking process developed in the 1930s by the French chemist Eugene Houdry in partnership with Sun Oil. The 100-octane fuel gave Allied aircraft engines a power density advantage over German engines burning lower-octane synthetic fuel. American refineries scaled production of 100-octane from 40,000 barrels per day in 1940 to over 514,000 barrels per day by 1945. This was the largest expansion of a specialized industrial product in human history. The men who ran the refineries, the chemists who developed the cracking processes, the engineers who built the pipelines were not famous and are not famous now, but they accomplished something that no other industrial system on Earth could have accomplished. They turned the American petroleum industry into the operational backbone of the entire Allied war effort. The number that German officers had the hardest time accepting was 800,000. 800,000 gallons of gasoline per day. That was the consumption of Patton's Third Army and Hodge's First Army in late August of 1944. Each American armored division was consuming roughly 95,000 gallons per day. Each infantry division was consuming about 40,000 gallons. The two American armies, with their armored divisions and their infantry divisions and their core artillery and their support echelons, were burning through 800,000 gallons per day combined. By comparison, the entire daily fuel allocation of a German army of similar size was less than 100,000 gallons per day. The Americans were consuming more than 8 times the fuel that an equivalent German operational formation was burning, and the Americans were complaining that they did not have enough. This is what the German officers could not believe. Not that the Americans had more fuel than the Germans did, they knew that. What they could not believe was the scale at which the Americans were using fuel. They could not believe that the Americans considered this normal operational consumption. They could not believe that the Americans had built a logistical system capable of delivering that fuel from refineries in New Jersey, across the Atlantic, through Cherbourg, through truck depots in Normandy, and to the front line within 24 hours. And they could not believe that when the Americans temporarily ran out of fuel because their supply lines could not keep up with their advance, the answer was not to economize, but to invent, in a 36-hour brainstorming session, an emergency truck convoy system that would move 12,000 tons of supplies per day across France for 82 consecutive days. The Red Ball Express was created on August 25, 1944, in response to a crisis that had emerged after the breakout from Normandy. American forces had broken into open country and were racing east at a pace that pre-war supply planning had not anticipated. By late August, Patton's Third Army was hundreds of miles from its supply base at Cherbourg. The French rail network, which the Allied bombing campaign had deliberately destroyed before D-Day to impede German movement, was useless. The only way to move fuel from the depots in Normandy to the front line was by truck. The Red Ball Express took every available truck unit, stripped its drivers out of combat support functions, and put 6,000 trucks on the roads of France, running day and night between Cherbourg and the front. The drivers, predominantly African-American troops from segregated quartermaster and transportation units, drove 20-hour shifts. The trucks were 2.5-ton GMC and Studebaker cargo vehicles, mostly the GMC CCKW that American troops called the Jimmy. Each truck carried 5 tons of supplies. The trucks moved in convoys of 40 or more vehicles, spaced 60 yards apart. The route was a one-way loop, eastbound on one set of roads, westbound on another. The trucks did not stop except to refuel and to change drivers. Vehicles that broke down were pushed off the road. The convoy consumed 300,000 gallons of gasoline per day just to deliver gasoline to the front. The system operated for 82 days. In that time, the Red Ball Express delivered 412,000 tons of supplies to 28 different American divisions. The 5-gallon jerrican deserves a section of its own because it is, like the bearing in an aircraft engine, one of the small things that made the larger things possible. The jerrican was originally a German design developed for the Wehrmacht in the late 1930s. American observers had noted its qualities during the Battle of France in 1940. It had a metal-stamped construction with 3 handles allowing 2 men to carry 1 or 1 man to carry 2. Its triangular cross-section made it stable when stacked. Its pour spout had a built-in vent that allowed fuel to be transferred faster than conventional gasoline cans. Its sealed construction kept the fuel clean even after rough handling. The American Army adopted it in 1941, calling it the jerrican after the British slang term for Germans, and built tens of millions of them during the war. The jerrican was the unit currency of Allied fuel logistics. Every American supply depot was stocked with stacks of jerricans. Every tanker truck unloaded into jerricans for distribution. Every tank, every truck, every armored car, every Jeep was refueled from jerricans. By late 1944, the U.S. Army had over 20 million jerricans in active service in the European theater alone. The Germans, who had invented the can, never quite understood that the Americans had taken their idea and built an entire continental logistics system around it. By the spring of 1944, Albert Speer, the German Minister of Armaments and War Production, understood that German synthetic fuel production was the single most fragile element of the entire German war economy. Speer had read the production reports. He had visited the synthetic fuel plants. He understood that if the synthetic plants were knocked out, the German war effort would collapse within months because the Romanian oil was no longer sufficient to make up the difference. What Speer worried about was that the Allied air forces would figure this out. The first 3 years of the strategic bombing campaign had concentrated on aircraft factories, ball-bearing plants, and city area bombings. These had produced significant damage but had not threatened the German war economy at its base. The synthetic fuel plants were a different matter. They were concentrated, they were vulnerable, they were difficult to repair after major damage, and they produced something for which there was no alternative source. If the Allies attacked them in force, the war was over. Speer had been thinking about this for 2 years. He had been quietly worried that the Allies would notice. By the spring of 1944, his worry was reaching the level of certainty. He waited for the attacks. He hoped they would not come. On May 12, 1944, 935 American bombers and their fighter escorts attacked the German synthetic fuel plants. The Luna Werke at Merseburg, the largest of the synthetic complexes, was the principal target. Other plants at Brooks, Politz, and Bolin were hit on the same day. The 8th Air Force, operating from bases in England, hit the targets with 1,000-pound and 2,000-pound high-explosive bombs delivered in a coordinated strike that had been planned for months. The synthetic plants were enormous installations, sprawling across thousands of acres, and most of the bombs landed somewhere on the target. Production at Luna stopped immediately. Production at the other plants dropped sharply. German fighter losses defending the plants were extensive, and the Luftwaffe could not afford the losses, but it could not afford not to defend the plants either. Speer would later say that May 12, 1944, was the day the technological war was decided. He sent an urgent memorandum to Hitler the following day. He told Hitler that the enemy had struck the weakest spot in the German war economy. He told Hitler that if the attacks continued at this intensity, German fuel production would collapse within months and German military operations would cease. The 8th Air Force returned to Luna 21 more times between May 1944 and March 1945. Each return forced the plant to rebuild. Each rebuilding took longer than the previous one. The collapse was sharp, brutal, and irreversible. In April of 1944, German synthetic fuel production had averaged 92,000 barrels per day. By September of 1944, that production had fallen to 5,000 barrels per day, a reduction of 95% in 5 months. By February of 1945, German production of aviation gasoline had fallen to approximately 1,000 tons for the entire month, which was 0.5% of the average monthly production in the first 4 months of 1944. After February, no more aviation gasoline was produced at all. The Luftwaffe had brand new aircraft sitting on airfields with no fuel to fly them. The Me-262 jet fighter was completing production at the rate of 200 per month in the spring of 1945. The aircraft were rolled out of the factories and parked at dispersal fields where they were destroyed in place because there was not enough J-2 jet fuel to fly them. The same collapse hit German ground forces. Panzer divisions began to consolidate their fuel into the minimum number of vehicles required for combat. Trucks were left behind. Wheeled vehicles were converted to horse traction wherever possible. By the autumn of 1944, German military trucks were being pulled by oxen across the Eastern Front because the trucks had no fuel. This is the context in which the Ardennes offensive was planned. By November of 1944, Hitler had decided to launch one final offensive in the West. The plan was to attack through the Ardennes forest, exploit a weak point in the American lines, drive to the Meuse River, and ultimately capture Antwerp, splitting the British and American forces. The plan required mobile armored forces. It required enough fuel to drive those forces from their starting positions in the Eifel to Antwerp, a distance of approximately 300 kilometers. The German planners calculated that they had enough fuel for perhaps two-thirds of the distance. The rest of the fuel, the plan said, would come from captured American stockpiles. The plan was approved by Hitler in early November and given the codename Wacht am Rhein. The principal armored striking force was concentrated under Field Marshal Walter Model. The 6th SS Panzer Army on the northern flank would carry the main weight of the attack. Its leading elements would be the 1st SS Panzer Division, with Joachim Peiper commanding a reinforced Kampfgruppe of approximately 5,000 men and around 160 armored vehicles. Peiper was 30 years old. He had been a tank commander since 1941. He had fought in Russia, in France, in Italy. He was given the responsibility of breaking through the American lines, racing west, capturing bridges over the Meuse before the Americans could destroy them, and continuing toward Antwerp. He was also given the operational assumption that he would refuel his tanks from captured American depots. Peiper protested. He was overruled. The attack began before dawn on December 16, 1944. The American defenders in the Ardennes were stretched thin. A relatively quiet sector had been used by the U.S. Army to rest divisions exhausted from earlier fighting. The first day of the German attack achieved tactical surprise. American lines were broken in several places. By the morning of December 17th, Peiper's column was through the initial American positions and racing west along its assigned route. The column had crossed into Belgium. It had taken some prisoners. It had executed some of those prisoners, including approximately 84 American soldiers from the 285th Field Artillery Observation Battalion at a place called Malmedy, an atrocity that would echo through American military memory for decades. The column was making good progress. It was, by mid-morning of December 17th, approaching the village of Bullingen, where an American fuel dump had been reported. The dump was there, the 50,000 gallons. Peiper's men captured it. The column refueled. The advance continued. The next major fuel depot in the path of Peiper's advance was at Francorchamps, near the town of Stavelot. This dump contained approximately 124,000 gallons of gasoline, considerably more than the amount Peiper had captured at Bullingen. If Peiper's column could reach it, refuel completely, and continue west, the operational plan still had a chance of succeeding. Peiper did not reach it. The reason was a young American officer named Major Paul J. Salas, an ordnance officer who had been left in command of a small American detachment defending the road through Francorchamps as Peiper's column approached. Salas had no anti-tank weapons. He had a rifle platoon, a few jeeps, and the fuel dump. He realized he could not stop German Tiger tanks with a rifle platoon. He could, however, ensure that the German tanks did not capture the fuel. Salas ordered his men to seize gasoline cans from the dump. They poured the contents into a deep road cut where there was no turnout. Salas lit the gasoline. 124,000 gallons of high-octane motor gasoline went up in a wall of flame that filled the road cut to a height of 50 feet and sent a column of black smoke rising over the Ardennes that was visible for miles. When Peiper's lead Tiger reached the burning roadblock, the German commander stopped, surveyed the situation, and turned around. The fuel that the operational plan had counted on him capturing was burning in the road in front of him. This is what Peiper meant when he told his interrogators in January that he had begun to realize he had insufficient gasoline. The realization was that the Americans were prepared to burn 124,000 gallons of fuel to deny it to him, and that the Americans considered this an acceptable cost of doing business. He had been working under the assumption that fuel was the most precious operational commodity in the war. The Americans were demonstrating that they had so much fuel that they could afford to burn most of one division's combat reserve as an improvised tank barrier and not even feel the loss. Peiper's column continued for a few more days. He pushed on towards Stoumont. He sent reconnaissance toward the Meuse. He fought through American counterattacks at Chenot and La Glaise. He requested air resupply, and one Luftwaffe transport mission attempted to drop fuel and ammunition to his position, but most of the supplies fell outside German lines. By December 23rd, his tanks were out of fuel. They were sitting in fields and on roads and in the streets of Belgian villages with their fuel tanks empty. His crews drained the last fuel from the least operational vehicles and concentrated it in the few tanks that could still move. Then those tanks ran out. By December 24th, Peiper had no more options. He ordered his men to set demolition charges in the abandoned tanks and to escape on foot back toward German lines, leaving behind virtually the entire armored strength of one of the most powerful Kampfgruppen the SS had ever fielded. The same pattern repeated across the entire Ardennes operation. Other German columns ran out of fuel. Other German tanks were abandoned. Other German operational plans collapsed because the captured fuel that the planners had counted on never materialized in the quantities required. By the time the Bulge battle ended in late January of 1945, the German offensive had cost the Wehrmacht approximately 100,000 casualties, 600 tanks, 1,600 aircraft, and most of the operational fuel that had been carefully accumulated for the offensive. None of those losses could be replaced. In the final weeks of the war, photographs began to appear that captured the absurdity of the German situation. A Tiger I being towed across a field in eastern Germany by a team of 8 oxen. A Panther sitting beside a road with its hatches open, abandoned because there was no fuel to move it. German operational reports from the last months of the war mention regularly that fuel allocations were running between 5 and 10% of nominal requirements. Combat units were being told in writing that they could not expect fuel for routine repositioning movements. They had to fight where they stood. They had to die where they stood. The famous photograph of the Reichstag in May of 1945 has a counterpart that is less famous and equally indicative. It is a photograph of a Luftwaffe airfield outside Munich in late April with 30 Me-272 jet fighters parked in dispersal positions, every aircraft fully equipped, every aircraft in operational condition, none of them flying because there was no J-2 to fuel them. The Me-272 was the most advanced fighter in the war. It was being produced at the rate of 200 per month in the spring of 1945. It was not being flown because Germany had no fuel. The airfield was overrun by American forces in late April. The aircraft were captured intact. They had been built, they had been delivered, they had been parked, they had never flown. The strategic lesson, which post-war military analysts have spent decades drawing out, is that mechanized warfare is, in its essence, an industrial economic activity rather than a military one. The capacity to make war the way the Wehrmacht intended to make war, with armored divisions and air forces and motorized infantry, requires fuel at industrial scale. A country that cannot produce fuel at industrial scale cannot wage industrial war for very long. Germany attempted to solve this problem through synthetic fuel manufacture, an engineering response to a geological deficit. The solution worked, partially, until the moment the Allies decided to destroy the synthetic plants. Then the solution failed. Germany had bet its entire war effort on the assumption that the synthetic plants would not be destroyed. The bet failed. The American war effort, by contrast, had been built on a structural foundation that the Axis powers could not match and could not even directly attack. The American oil industry was located on the North American continent, beyond the reach of any Axis bomber or U-boat or saboteur. The refineries in Bayonne and Beaumont and Wilmington were untouchable. The wells in Texas and Oklahoma and Louisiana could not be bombed. There was always more fuel. There was always more aviation gasoline. There were always more jerricans, more trucks, more depots, more refineries running at full capacity in places that German bombers could not reach. The German officers who survived the war and wrote memoirs afterwards, men like Albert Speer and Heinz Guderian and Hasso von Manteuffel, all converged on a single conclusion. They had lost the war on the production side, not on the battlefield side. They had been outproduced, not outfought. The German army had been in many ways the most tactically competent army in the war. The German Air Force had been, in many ways, the most operationally innovative air force in the war. None of it had mattered. The Allied industrial machine, and specifically the American industrial machine, had produced fuel and tanks and aircraft and ammunition at a rate that no amount of German tactical excellence could overcome. Joachim Peiper himself survived the war as a prisoner of the Americans. He was tried at the Dachau trials in 1946 for the Malmedy massacre. He was sentenced to death. The sentence was commuted to life imprisonment. He was paroled in 1956. He moved to France in 1972 under an assumed name. In July of 1976, his house in the town of Treves was firebombed in retaliation for his wartime activities. He was killed in the fire. He left behind, among other things, the interrogation reports from 1945, in which he had testified about the moment in December of 1944 when he had begun to realize that the gasoline was not going to be there. In a war decided by what arrived in time, the fuel arrived in time. It arrived from refineries in places that German bombers could not reach. It arrived in tankers that crossed an ocean that German submarines could not close. It arrived in trucks driven by men who had not been recognized for it before and have not been recognized for it since. It arrived in 5-gallon jerricans painted olive drab and stenciled with white block letters. It arrived everywhere, in quantities the German army had never imagined possible, at a tempo the German army had never imagined achievable, sustained for a duration the German army had never imagined could be supported. And the German army, looking at it, understood that it had been beaten before any of the famous battles of the famous campaigns had even begun. Joachim Peiper, standing in the snow at Bühlingen on December 17, 1944, surrounded by 50,000 gallons of high-octane American gasoline that had been left unattended in a field for his Kampfgruppe to find, was looking at the future. The future was American fuel everywhere, in unlimited quantities, supplied by an industrial system that nobody on Earth could match and that no European power would match for the next 40 years. He refueled his tanks. He continued his advance. He ran out of fuel 6 days later and walked back to Germany on foot, leaving his armored vehicles behind him in Belgian villages where they would be photographed by American Signal Corps cameramen for the next month. The war was over for his Kampfgruppe before it was technically over for his country. The reason was the gasoline. In a war fought between industries, the country that could not refine its own fuel was the country that lost the war. Not because its soldiers were not brave, and not because its engineers were not skilled, but because the geological hand it had been dealt was inadequate to the kind of war its leaders had chosen to fight. The Germans understood this. The Americans understood it too, but in a different way. The Americans had built over 100 years of industrial development, a petroleum infrastructure that nobody on Earth could match. And when the war came, the infrastructure simply did what infrastructure does. It produced, it delivered, it fueled the armies that were sent to fight. In a war decided by what worked was the gasoline. There was more than enough. In the snow at Bühlingen, an SS Obersturmbannführer understood this in a moment, and the moment was the moment the war ended for him, even though the fighting would go on for another 5 months. The fuel was the war. The Germans had run out. The Americans had not. That was, in the end, the whole story.